Today we're going to be talking about the zero product property, aka the ZPP. And this one is so important that I've even let my hair down for it. Prior knowledge that you'll need to have for this one is evaluating functions, and I want you to remember that evaluate means to like plug in for x or n or whatever the input is and calculate. Okay, so it's plugging in inputs to get outputs. Multiplication, so just multiplying numbers and stuff, that kind of goes with this. And then factors, and I want to remind you that a factor is a number you multiply to get something else. So for example, we've used this before, 12 is 3 times 4. So 3 and 4 are a factor pair of 12. They are factors of 12. And all the factors of 12 would be 1, 2, 3, 4, 6, and then 12 itself, okay? But we're going to use it in terms of expressions this time. So let's go ahead and start out with this, and we'll tell you exactly what the ZPP is. Generally, I find that students don't have too hard of a time understanding this one. It states that the product of two numbers is 0 if and only if one or both of those numbers is 0. Now I remind you, we've talked about this before, but the phrase if and only if just means that it goes both directions. So if the product of two numbers is 0, then one of these numbers is 0. But also you can go the other way. If one of the numbers is 0, it means the product must be 0. It may be easier to understand in this case with symbols. If AB is 0, then either A is 0 or B is 0. And of course, if you start with one of these things, it must make that true as well. We're going to take a look actually at some patterns in the multiplication table right now for a little bit first. And I'm going to introduce this to you, or reintroduce this to you, because we're going to end up using this here and there as we go through future lessons. So let's go ahead and look at that right now, and then we'll come back together and we'll do some examples, more examples on the ZPP.
So let's go ahead and look at the multiplication table here. I'm just going to zoom in because we're going to focus just on the positive portion. We've looked at this before, and we've filled out the negative parts, and we've looked a little bit at patterns and stuff. But I want to remind you today kind of how it works, and then use this as a jump-off point for today's lesson, because we're going to use this in future lessons for the rest of this course here and there, because the patterns in it are really important to help us understand how the numbers are working and the algebra concepts. So just as a reminder, every entry in this comes from the product of two numbers. So for example, here, if I go to the third column and I want to multiply 3 times 5, let's say, then I go up to the fifth row, and 3 times 5 is, of course, 15. Now, remember, that's actually a different order than if I did 5 times 3. And I think we're okay understanding that 5 times 3 gives us the same result, but it's technically a different way of getting 15. So you'll notice the companion 15 here that comes from 5 first and then 3 second. So you'll notice a lot of patterns in here that revolve around that. Today's focus is really going to be looking at all the numbers that are along the axes, like the x and the y axis here. And it helps us to look, and we can see all the patterns here in these rows and columns, and they all lead back, once they get on the axes, to needing to have a 0, right? If you look here, 7, 6, 5, 4, 3, 2, 1, 0. And these are going by 2s, but it still needs a 0 there. And so those patterns agree. And not only does that agree, but we kind of also understand, I think, that when you multiply something by 0, you always get 0. That's why there's zeros all along the x and y axis. But it makes sense, because if you look here, 2 times, well, we haven't gone up or down, so 0 is still 0. But even if we go the other direction, if I go 0 in the x-axis times 2, I still should get 0. And all the patterns in here still work with that. So we're going to be working with products that make 0 today.
Look at some the most well-known types of equations that we'll see that involve use of the zero product property. So here's what I want you to do. Let's go ahead and just start by looking at A, and I want you to really carefully try to just solve this right now in your head. Find any number or numbers that you think are going to make this true. And you don't need to pause right now. You can probably just look at it and think for a moment. Now let's go ahead and check and see if you got it right. So here you see that we have a product of two things. We have x plus 3 multiplied by x minus 14. So that makes this a candidate. In fact, all of these are in that same structure. We have a product of some things equaling 0. So they're all able to use the ZPP concept. Now here's where the trick is. You can't just say, okay, 0 is a solution. We have to think about what inputs, okay, make an output of 0, meaning what x values are going to actually make that work. Well, in this case, we can see that we know that either the left thing equals 0, or else the other one equals 0, or both, of course, right? So if x plus 3 equals 0, we can see that x equals negative 3, or for the other one, if x minus 14 equals 0, we can see x equals 14. Now, I don't expect you to necessarily write out the separate equations every single time. In my experience, most of the time students are able to look at this and say, oh, okay, well, if I plug negative 3 in here, negative 3 plus 3 times negative 3 minus 14, this negative 3 plus 3 becomes 0. And 0 times whatever is just always 0, right? So it's this idea of kind of working one of those backwards to figure out what number goes here to be it's usually the opposite, but we're going to see something in part B that's makes it so it's not always that, okay? So I want you to go ahead now that we've talked about this, I want you to pause for yourself and do the remainder of these, B, C, D, and E. And if you get stuck, that's okay. You can unpause it and check the solution, or you can just skip and look at the solutions afterwards. Okay, so let's go ahead and look at this. For this one, what's going to make this guy equal 0? Oh, that's easy to see. X equals 6, right? But the problem for this one right here is, if it's hard to do in your head, that's okay. It is x equals 2.5, but if you weren't able to do that, remember, 2x minus 5 must equal 0. And if 2x minus 5 is equal to 0, that leads to 2x equals 5, and then when I divide by 2, I can say 5 over 2 or 2.5, okay? So it's fine to leave it as a fraction, that's because it's equivalent to 2.5. But those are our two values that make it 0. Let's look at the next one. This one, actually let's go back here like I said. If it's just x and there's no other coefficient on x, you can see that the solution that comes from that one is, from that factor, is just the opposite of what this is. But it wasn't quite the same here right now, because remember, in this case, I need 2x itself to equal 5. So we need to figure out what x that I multiply by 2 gives me the 5, so that when I subtract it, it makes 0. Okay, so all these backwards thinking things and backtracking come back that we've done in the past. And that's actually something I could probably list up here that I didn't originally here, is that backtracking is a helpful prior knowledge, actually. So let's solve this one. You should get x equals negative 4 for that left piece, and if this one's again a little bit hard to do in your head, you can just solve it, on the side. 12x plus 3 must equal 0, right? If that whole thing equals 0, that's one option to make, if 12x plus 3 equals 0, that's one option to make the whole thing equal 0. And then we'll subtract 3 and get 12x equals negative 3. And this one you want to be careful. It's easy to say that the answer to this is negative 4, but because we're dividing the 3 by the 12, negative 3 by 12, then it's actually not negative 4, it's negative 1/4. So negative 4 or negative 1/4 are the two choices there. Okay, let's take a look at D. This one's a little interesting, and I included it like this on purpose because students will often look at one like this and accidentally say that this one creates a solution of x equals like minus 2 or something like that. But I want you to remember, this is not like these other ones where it was like x plus something or x minus something, okay? This is just 2 times x, blah, 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 blah. Can you think of a really simple number that you could put here to make the whole thing just collapse to 0? That would just be 0. So actually this piece just gives me, and that 2 doesn't really make a difference. I could have 1 million there, and still that x, if it's multiplied, is still just 0. And then my other solution here for this piece is negative 21. And E is a little bit interesting because it doesn't just have two pieces anymore, right? But the good thing is it still applies. This says the product of two numbers. Technically, the ZPP could be stated two or more numbers, right? And I think we could all believe that. So there's actually three solutions for this one because there are three factors being multiplied and they're all different. One thing to mention is, like, if I had this guy here being x minus 7, like it was a repeat, which is fine because that's still, you know, another function that exists, there would actually only be two solutions because, or two different ones, because these two factors are identical, okay? But ours in this case, because we have three separate different factors, is going to have three possible solutions. So we get 7, this one creates negative 3, or 2x minus 1, and remember, if you need to, solve it on the side. We'll add 1 and divide by 2. X equals 1/2, or you could say 0.5 if you want, of course. Okay? So there's our first example. Let's go ahead and look at our next example. Example 2. Let's suppose Jack is trying to solve the equation x plus 7 times x plus 11 equals 77. And he says, oh, that's easy. X equals negative 7 or negative 11. Those are the solutions. Think really carefully about this. I asked, what's wrong here? Okay? And then how could we solve this, or how can we solve this? I want you to think about that for yourself real quick. You can pause the video for a moment, and I want you to think about these two questions and how you'd answer them, okay? So let's take a quick look at this. Remember, our ZPP, our zero product property, relies on a product equaling what? 0, right? In fact, all the other examples we looked at here in number 1, the only way we could apply this zero product property was that the product equals 0 for every single one of them. What's the problem here? It's equals 77, not 0. So I actually cannot apply that zero product property here. Now, to address the next question, I guess I should answer this, right? It equals 77, not 0, right? So there's our main answer to that one. So let's go ahead and answer, how could we solve this? Well, to be honest with you, we have some methods that we could use, but you and I are going to end up spending some time looking at that later on. Although actually, now that I look at this a little deeper, I think we could actually tackle this if we tried to in that way. But another way that's always, sometimes students forget this, but something that's always acceptable is just trying to plug in some numbers and be creative with your thinking. In fact, if you think really carefully about it, I'll bet you can see a relationship between 7 and 11 and 77. And maybe that'll help you think of one of the solutions for this. If you didn't think of that yet, actually, look, if you plug in 0, it works. Because 0 plus 7, and remember, when we're talking about it, it has to be the same number that plugs in for both x's, right? Because otherwise we'd have to use a different variable. So if this was 0 and 0, then we get 7 times 11, and it works. That's pretty cool. Let me show you another way. Okay, so we'll list this in. So I'll say plug in or guess and check is, of course, a way we could do it. But let's actually think about that we could expand it and simplify. But you know what I'm going to do here is I'm going to use this as our example 3. So let's go ahead and we'll do it over there as a new example. So we see Jack's equation again here, but we're going to look at it a little bit more of a methodical algebraic way, and we'll get much more into this in future lessons. Solve the equation by expanding, setting equals 0, then factoring. That's kind of a lot, but don't worry about it. We'll lay this out together. So let's start by expanding, okay? So I'll write those steps out as we go. So I want you guys, well, we may have to do this on the side. Now, I really recommend using, trying to get to the point where you can do these in your head, because that's always going to be something helpful to be able to do. But again, if you need to, you can use an expansion box. hopefully you recognize that we end up adding the 7 and 11 to get, well, first of all, we have x squared, and then we're going to have 7x, and then we're going to have an 11x, and then we're going to have a 77 equals 77. Now if you use the expansion box, x plus 7 and x plus 11, doesn't look like a 7, gives me x squared, and then 7x, and then 11x, and then 77. So you'll notice that's exactly, if I add all that up, remember, it's exactly what I got here. So what I have here is x squared plus 7x plus 11x gives me 18x plus 77 equals 77. Okay, so there's the first part I said, and then I said set equal to 0. So let's go ahead and write that next. Set it equal to 0. Well, remember, that's how I have to solve using the zero product property. It's got to be equal to 0, right? How can I make this thing equal 0? What should I do to both sides? I should subtract 77, right? But you'll notice something interesting here. Ooh, both of these have a 77. So when I do that subtraction, then this equation becomes x squared plus 18x. And when I subtract, I guess I'll write that in here. When I subtract 77 from here and from here, they become 0. So what I have is nothing left there and 0 on the right side. Oh, that makes sense? Okay, so oftentimes that's how we have to deal with these if we're not just going to guess and check and plug in, which of course is always totally okay if you're stuck, okay? But in algebra we do like to have methods to do for things. So we've set it equals 0, and then it says factoring. So let's go ahead and get to that, okay? So expand, set it equal to 0, and factor. Well, let's go ahead and finish this off. I want you to think about this. This right now is not factored, right? This is not able to use the ZPP right now because it's actually a sum. It's not like something times something, right? Remember that if this was equal 0, we'd be able to solve it right away because Jack would have been right. It would be -7 and -11, right? And that's because this is in factored form. So we need to figure out, can I take this guy right here and write it in factored form? Essentially what we're doing is we're going to reverse distribution. This is itself a simpler example, so let's take a look at it. X squared plus 18x equals 0. Actually, there's an x I see that I can think backwards here that you could take out of each of those two terms, right? Each one of these shares a factor of x. And you can just think backwards. If you distribute this in, we get x squared plus 18x. But now we're ready to actually solve it with the ZPP, right? So that would be the last thing, and I guess I'll write that here as my last step here. And we can see that x equals 0 or -18, and there we go. We're going to look into an equation that's kind of similar to this, but talk about it a little bit more deeply now in our next example, and then we'll wrap up with just a couple more. So before we jump into a few more examples, one thing to make note of here that is really important that you have written down is that the ZPP only applies to factored form, which I kind of mentioned a moment ago. Let's just look really quickly at something here. So let's say we have this equation here. It's kind of long and crazy looking. 2x cubed minus 9x squared minus 38x plus 21 equals 0. Well, the thing is, as I mentioned a minute ago, this actually is not just written out as the product of something times something times something, right? And so this guy right here, you can't just solve it as is. We'd actually have to figure out, and we'll learn this later on, probably more like in a later algebra course, how we could actually take an expression like this and break it apart completely into all of its factors. Well, it turns out actually that this one, let me double check my earlier example because it's actually equivalent to x minus 7 times x plus 3 times 2x minus 1 equals 0. That should look familiar to you. Okay? So you can see how the form something's in can make it really helpful or unhelpful to solve it or maybe graph it or do lots of things to it. And we've been kind of learning that theme throughout this school year. And so at this point, of course, we know, like we already said, x equals 7, negative 3, or 1/2 are the three solutions. And we would not have been able to tell that easily from the original thing, right? Let's go back over now and finish off a few examples, and I think we'll do one more after these and we'll call it. So let's solve this guy. Is this in factored form? I want you to look really, really carefully. There's something that's a very slight little problem here. It's going to be related to our example 3 we did just a few moments ago, all right? But it's not quite like there yet. This is not in factored form because you have this pesky plus 12. If this was gone, okay, we'd be good and we could just solve it. It's an easy one. But because of that plus 12, there's a problem. Well, let's use what we did a minute ago where we said expand, right? Set equals 0, and then factor, right? Since we already did that, why don't you go ahead yourselves and expand it and simplify it and then see if you can finish it off, okay? Go ahead. So let's go ahead and look at this. If you multiply x plus 3 times x minus 4, we should get x squared minus 1x, so just minus x minus 12. Because you're going to have a 3x and a minus 4x when you add them together. And then we have that plus 12 at the end equals 0. And then it's going to look like the format that we had before. Okay? So this minus 12 and plus 12, those cancel each other out. And I'm left with x squared minus x equals 0. And then it looks like I can actually factor an x out, and it leaves me with x minus 1. Sometimes this x, like what if I take an x out of here, confuses students. Like, is it 0? Is there nothing left? Just remember, it's like the reverse distribution. So if I were to multiply the x in there, it would be a minus 1. And so my solutions are x equals 0 or positive 1. Okay? Now let's look at some similar ones. We can actually apply what we just talked about like a minute ago. Except these ones I actually don't think we need to do any expanding yet. The reason why I chose the examples here in number 5 is because it highlights something that a lot of students tend to do. I'm guessing you can actually look here at this equation and find one number that works, that's a solution for it, right? Maybe you didn't see it, maybe you did, but if you have 0 for x, it works, right? Because 0 cubed is 0, and 25 times 0 is also 0. And in fact, you can see the same thing for part B. Okay, so these are very similar equations to each other. So we know that 0 is actually a solution. Here's a mistake sometimes students make here, and I'm going to do this off to the side because it's not entirely wrong, but it's not entirely right. Okay, so this is going to be kind of an oops thing. Sometimes students will do x cubed equals 25x, and then I'll see them, they'll want to divide by x and divide by x, and that leaves me with x squared equals just 25. Well, that's nice because there's no x on the right side anymore, and then we can just think about any numbers here to solve this one, right? Can you think in your head? There's actually two numbers that you could square to get 25. It could either be x equals 5, or it could be x equals negative 5, right? That's a little bit of an oops here, and we're going to see why and tackle it in the proper way here together. So let's go ahead and do this. We're going to actually do exactly what we said before. We're going to set equal to 0, and then we're going to factor. So x cubed minus 25x equals 0. You see what I did? I just subtracted 25x off of both sides of the equation. And then we're going to think, wait a minute, x times x squared minus 25 equals 0. We can factor that x out. Notice they both share one single x. Okay? Now here's where we get to something that's different. Remember how we solved it in our heads and we knew obviously that 0 was a solution? In our oops over here, this didn't give 0. It only gave 5 or negative 5. Where did that 0 go? Well, it turns out when we divided by x, we actually left out a solution that actually works, and we don't want to leave any solutions out. So this guy's going to make it more proper, because look, we can use the ZPP. We can say x equals 0 from this piece, or we can say that x squared minus 25 equals 0. And you and I both know then we can add the 25, and we can get x squared equals 25 here. Now we actually can solve this out. Whoops, I forgot to use orange. That's my normal color for answers, for solutions. X equals 0 or 5 or negative 5. This one turns out to have 3 possible solutions. So that's just something to be careful of with these kind of things. And I want you to do this on your own now, the second one, part B, just like we did part A there. Okay, so pause right now and do that, and then we'll look at the solution. Okay, let's look through the solution. I guess since I used blue there, I'll use blue here. 2x cubed minus 32x equals 0. Now, there is definitely an x there, but there is also a 2 that you could pull out of these. A 2 and an x. And watch, it leaves x squared. Because let's think backwards. 2x times x squared, if I distribute it, is going to give me 2x cubed. So that does work. And this is going to leave in here a minus 16, I believe. Right? And again, think backwards. 2x times 16 is 32x. Okay? So minus makes minus. And then what we're left with here is, okay, well, if I have 2x equals 0 or x squared minus 16 equals 0, okay, we can see that gives me x squared equals 16, and so x equals 4 or minus 4 from this one, and then from this one, x just equals 0. Okay, so we have 3 solutions again. X can either be 0 or 4 or negative 4. The type of problem that I think is worth us looking at is basically going to be thinking backwards, because a good old dose of thinking backwards is really helpful for us sometimes. Okay? So this is going to be going back to the ideas of the ZPP, but we're essentially building an equation with solutions that are given to us. So it says write an equation with the given solution. So part A, if we want an equation with x equals 7 and negative 12 to be the solutions, what's an equation we could write? Why don't you go ahead and try to do that yourself right now for a moment. You can pause right now and try that, and then in fact you can try all 3 of these. And if you're a little bit stuck and you're not sure what to do, you can keep watching and I'll go through it together right now. Okay, let's go ahead and check your answers, or if you weren't sure, just remember, if I have 2 solutions, that means I have 2 factors that could equal 0, right? And this isn't like the absolute only way to make an equation that has these 2 solutions. But for now, since we're using this, the ideas from this lesson, this will be an easy way to make this. So if I need x equals 7 or negative 12, then x minus 7 and x plus 12 will work. It's pretty simple, isn't it? And again, remember, if I plug in 7 here, that makes this piece be 0, so that it collapses to 0, right? It makes the whole thing become 0, equals 0. And the same thing here, this negative 12 plus 12 makes that 0, and that makes the whole thing 0 as well. So those are 2 x values that we could plug in that make it all equal 0. Let's go ahead and do the next one. Well, I have 3 here, so I know that it's possible to have 3 factors. Okay? And x equals 2, x minus 2 is the easiest one, x minus 15 for that one, and then x plus 3 equals 0. Does that make sense? Now, there's a couple things I want to mention. Like, if you really wanted to be creative with this, you could actually make some other things that would work out. For example, if I did like 2x minus 4 for that piece, technically speaking, if I do 2x minus 4 equals 0, then that gives me 2x equals 4 and x equals 2. So we can see that, or you can just check, plug in 2 here, you can see that still works, right? Well, that means there's many different equations we can make that fit this, to be honest with you. I do want to point something out. Notice that this, in this case, has a 2 that you could actually factor out. If I factored a 2 out of this and this, it would leave me with x minus 2 there, which looks just like my original one, except there's just another number out here. But remember, if there's just a single number out there, that doesn't really affect much. I could put 1 million in the front, like we said earlier, and still 2, 15, and negative 3 would make the whole equation still equal 0 once I multiplied everything out. 0 is really powerful, actually, isn't it? C might be a little bit tricky, but if you think about some of the ones we've done before, you could look back at that. The easiest way to do this would be, in this case, 2x minus 1. And just remember, if this piece equals 0, if you add 1 and divide by 2, we get our 1/2. And this will work in a very similar way. 4x minus 3 equals 0. That would be the easiest way to write an equation for that one. So again, happy math, and we'll see you in our next lesson.